Hi friends, in the first video we will be seeing the introduction to Ayer's criterion or how to obtain the characteristic equation. Here I told you I will solve the problem related to the shortcut which I have told you in the previous video. Now here we will apply the Ayer's criterion for this. Okay. So what is the highest order here? 3. Okay. That means when I draw my table, first is 3. Okay. So what is the coefficient of S cube? 1. Next highest coefficient of the same power, that means not if the started with 3, that means next odd power highest. What is the next odd power highest? That is S power 1, its coefficient is 3. Okay. Similarly S square next. What is the coefficient of S square? 6. Next highest power S power 0 in the odd, that means 10. Okay. Next I need for yes. Now here for us I told you we multiply and divide by the coefficient. Now here 6 3s are 18. 18 minus 10. How much? 18 minus 10 is 8. Divide by 6. Okay. So here we don't have any other values, so 0 0. Again consider same 0 0. I get 0 here. Okay. So here this is, you can say 4 by 3. These are least power here have. Okay. Now S power 0. S power 0. 4 by 3 into 10 minus 6 into 0. That means 40 by 3. Divide by 4 by 3. That means I get 10 here. But I hope you understood the terms. Okay, I'll show you one thing. For this, 6 into 3 minus 1 into 10 by 6. I got this term. Similarly, for this, 10 into 4 by 3 minus 0 into 0 by 4 by 3. I got 10. Okay, now. So I got every term on the first column. Now you can see here. From 1 to 6, any sign change? No. 6 to 4 by 3, any sign change? No. 4 by 3 to 10, any sign change? No. So total number of sign changes is 0. Then there is no sign change in the system. Then such system is called stable system. Okay. I hope I am clear with the explanation. Okay. Similarly, I'll consider the higher power terms now. We'll solve one thing. So they have given this question in the GATE exam, 2s cube plus 3s square plus 4s plus 5 is equal to 0. So this is the question they have given, and they are asking number of poles that lie on the right side of the plane. They are asking number of poles on our right hand side of this plane is how many? This was the question. Okay. So whenever I consider the number of poles on the S plane, they are asking if the pole is on the right hand side, that such system is called unstable system. That means they have clearly mentioned the system is unstable system, but they want us to know how many poles on the right hand side. Okay, the system is unstable because it has poles on the right hand side. Even though it has on the right hand side, I want to know how many poles are there. Okay, so out of 4, now I need to go for S power 4, S cube, S square, S power 1, S power 0. Okay, now for the S power 4 terms, 1, and next is 3, next is 5. Okay, next for S cube terms, 2, 4 and 0. Here 2 3 is 6, 6 minus 4, 2, 2 by 2, 1, 1 and 2, 5 and 0, 2 5s are 10, 10 minus 0, 0, 10 by 2, 5. Here 0. We don't have the value. Next, consider these two. 1 4s are 4. 4 minus 20 minus 16. 4 minus 10 minus 6. Minus 6 by 1 minus 6. 2 1 0 0. 0 1 into 0 0. 2 into 0 0. Again 0 will be. Here minus 6 into 5 minus 1 by 0, 1 into 0 by minus 6. Okay. Okay, I hope I'm clear. Now, here, there is any sign change? No. There is any sign change? No. There is any sign change? Yes. Here we have one sign change. And again minus 6 to 5. There is any sign change? Yes. Two sign changes we have. That means there are two poles on right hand side of S plane. Two poles on right hand side of S plane. Okay. So in this way we can easily derive the relation or derive the problem. Okay. Next. So these are all, I will say these are all comes under case 1 type of problems. Okay. These are all I can say they comes under case 1 problems. Now I'll solve for, I'll tell you other case. Case 2 problems. Case 2 problem deals with what happens is here if 0 occurs in the first column of RH table, then what to do? Okay, whenever we get the zeros, then what to do? First thing is that replace 0 with some constant. Replace 0 with some constant. Okay, next. Make the auxiliary equation. Make the auxiliary equation. When should you make the auxiliary equation? This is by the condition when entire row is 0. You can call it as row of 0. Okay, we have clause and we have subclause also. Okay, we have a condition. By the condition also we have condition. When the entire row is 0, then only make the auxiliary equation. If not, no need of auxiliary equation. Okay, now I can say this is as I consider this as case 3 problem. Here it is case 2 problem. Okay, whatever the thing is there, if it is 0 in the first column, replace it with 0, replace it with epsilon and do the problem as usually. If the row is 0, then you make the auxiliary equation. Okay, remember these two kinds. Okay, we will deal with the problem, you will understand how to solve. And first I will do a case 2 problem. So the given question is s power 4 plus 2s cube plus 2s square plus 4s plus 8 equal to 0. So this is the question given and they are asking for the stability of the system. Okay, find the stability. That means the system is stable or unstable. Okay, now for this, as usually we need to go for whether it's stable. Why not? Why? Because this is the fourth power. We cannot define directly for third power. We can define it for third power, but which is a fourth power. So I'm going for the whether it's stable. S power 4, s cube, s square, s power 1, s power 0. Okay. Now coefficients are 1, 2, 8. Similarly 2, 4, 0. Now 2 2s are 4. 4 minus 4, 0. Here I am getting 0. 1 2s are 2. 2 8s are 16. 16 by 2, 8. Now what do you do here if I get 0? Just replace it with epsilon and continue your process. Okay? No need of panicking or no need of stopping the problem. Wherever I got 0, I am putting epsilon. Write down for yourself, epsilon is 0 if you don't remember. Okay, next. Continue the process, that's it. Now it is 0. Epsilon into 4, 4 epsilon. Minus 8 to just 16 by epsilon. Now here, 2 epsilon 0 0, this is always will be 0. Now here, 4 epsilon minus 16 epsilon by 8 into 8 by 4 epsilon minus 16 by epsilon. I get 8 here. I get 8 here. Now this is 0 here. Okay? Okay. Now they are asking the stability. So any sign change here? No. Any sign change here? Epsilon is 0. Positive only, don't worry. No. Any sign change here? This we need to know here. How I need to know? 4 epsilon minus 16 by epsilon. What is the epsilon tending to? 0. Epsilon tending to 0. Then 4. Take epsilon common. Minus 16 by epsilon. By epsilon. I'm sorry. It won't be in epsilon. 16 by epsilon. When epsilon is 0. 4 minus infinity. Okay? Epsilon is 0, 4 minus infinity. Okay? This is, okay, let it be, minus infinity is a very large number, it will be some minus 24 or something. Then this is minus 20. Whatever it might be, this infinity is greater than 4, so this figure or this figure it always will be less than 0. Maybe it gives a negative number. Okay? So, there is one change here. If it is negative, then it is also positive. It is positive. Another sign change here. Okay? That means the given system is unstable system. Why? Why? Because we have two poles on RH side of S plane. This is very important. We have two sign changes. So two poles on the right hand side of the S plane. The given system is not a stable system. Okay? Now, the next question. Then the next case will go. Okay? The next case is, let's say it is case 3. Case 3 question. Okay, these are the kind of sums which you will understand if I do the sum only directly without telling the theory related to the case. Okay, that's why I started with the sums directly. You don't need to worry. If you have any doubts related to any concept in this which I am explaining, you can ask in the comment box. Feel free to ask and I'll reply you within no time. 3s square plus 2s plus 2 equal to 0. Oh my god, such a big equation. So this is the power 5 equation and this is the characteristic equation given. Okay, now they are asking the stability of the system. Okay, what kind of stability of the system is this? Now easily, again going back to our normal procedure, we can do it. Okay, I consider s power 5, s power